welcome to our day 9 notes for our Upward Bound Integrated Math 2. Today is actually our last day of notes, and I kind of messed around with the order of these topics a little bit. I did want to be around and on campus for at least one day of factoring, and that's what we're going to be talking about today. But we're going to be solving quadratics by factoring. Okay, and here it just says, we've dealt with factoring with expressions, and now we're going to move on to equations. And what we like to do with equations, we really like to solve them. So that's what we're going to kind of focus on today, is how to solve these. And the main thing that we're going to use is this zero product property. What that means is the zero product property just says that A and B are any numbers. And if A times B equals 0, so that's where it gets its name, A times B, so that's a product. So if the product of two things is 0, that's where the zero product comes from, then one of those at least has to be 0. And we say in that case that A equals 0 or B equals 0. Now that could mean they're both 0. All right, you could say that they're both 0, and that's always the case in math. Whenever you see or, it's really an and/or in that case, in that position. So on this first one, we're going to look through and follow these steps to solve this polynomial. It says first step is to get 0 on the right-hand side. So I'm going to do that by moving that 75 to the other side. Minus 15a minus 75. So I move that 75 to the other side by subtracting it, and I get 0 on the right-hand side. My second step is that I want to factor the left-hand side. I notice that all three of these, that's not right, hold on. All three of these are multiples of 3. And so on the first one I get 2a squared minus 5a minus 25. And that still equals 0. Now, we could kind of use that zero product property right here. I have two things being multiplied together. I have 3, and I have 2a squared minus 5a minus 25. So one of those has to be 0 in order for this to be true. I can't turn a 3 into a 0. I can't do that. There's no variable in this first thing to turn it into a 0. So I'm not even going to try, but it's going to hang out with us throughout the problem. I'm going to use our bottoms up method. So the first thing I want to do is to multiply that 2 to that 25. So minus 5a, and that's going to be minus 50. And that's going to equal 0. So I have to find two things that multiply to negative 50 and add up to negative 5. So when you think about those numbers, I'm guessing there's going to be a 5 and a 10. One of them has to be negative to get us to a negative 5. So we're going to use negative 10 and positive 5. So we get 3 and then a plus 10. Sorry, a plus 5 and a minus 10. And then you have to make sure that we know we're doing the bottoms up method. So that 2 has to go there. And this one doesn't reduce, so we're going to put that 2 in front of the a. So we get 2a plus 5. This one over here does reduce, and we get a minus 5. So now I have a list of 3 things being multiplied together, and this zero product property doesn't just account for 2 numbers. It goes on, it continues to go. So even if I said a times b times c equals 0, then a equals 0, b equals 0, or C equals 0. So it continues to progress. It can go on to a string of infinite numbers to get this same idea. So now we've factored it, but we haven't solved it. Okay? And that's, again, where the zero product property comes into play. Can I turn 3 into 0? No, I can't. There's no variable there. There's no value of a there that I could plug in that's going to turn 3 into 0. So I don't worry about that. But this term right here, or this expression right here, has an a, this factor. Okay, there's 3 factors that multiply together to give us 0. So this one has an a, and this one has an a. So I can find a's that will work for either one of these. The way I do that is I set it equal to 0. So the zero product property really brings us to either 2a plus 5 equals 0 or a minus 5 equals 0. Okay? So now the last thing I have to do is I just have to solve these 2 equations for a to figure out what a can be. Well, this one is probably the harder of the 2, but I would subtract 5 and then divide by 2. So a is going to equal negative 5 divided by 2. Or, on the other one, all I have to do is add 5 to both sides. And these are my 2 answers. Okay, all of these are going to have 2 answers, and that kind of brings us to something that I don't have as far as notes, but anytime you're trying to solve an equation, the degree of the polynomial tells you how many possible answers there are. And in this case, the degree is 2. The highest power on the variable is 2. So there's 2 possible answers. If this was a 3, there would be 3 possible answers. We're not too equipped to solve equations like that quite yet. We want to start off here. But if you think about any equations you solved in the past, you know, ones that look a little more like this, okay, the degree of this is 1. So there was 1 possible answer for this equation. It's kind of neat to know. So I will say that that was one of the, well, I'm not going to say one of the harder ones, but there were a lot of steps in there. There was a common factor. We definitely had to work to get 0 on the right-hand side. Sometimes you'll have to do that. Sometimes you won't. In this next one we're looking at here, step 1 is already done. I have 0 over here. So that's good. And the left side's already factored. Even better. All I have to do is step 3 to use the zero product property. Can I turn 4 into 0? No, I can't. There's no x involved to be able to turn 4 into 0. So all I'm left with is either x plus 6 equals 0 or x plus 3 equals 0. And then hopefully we can solve those equations pretty quickly. Subtract 6 from both sides. Equals negative 6. Or subtract 3 from both sides. X will be negative 3. And those are my 2 options. That's my answer. Either x equals negative 6 or x equals positive 3. Let's look at what happens if we try one of those answers back in our equation. If x is negative 6, the 4 stays as 4. Negative 6 plus 6 is 0. And then this over here, negative 6 plus 3 is negative 3. But if you notice, 4 times 0 times negative 3, well, 4 times negative 3, that's negative 12. But when we multiply it by 0, we get 0 for an answer. That's where the zero product property comes into play. And just know that, you know, it doesn't follow for anything else. Like there's not, you know, this one said 75 over here. There's no way to tell you that, or there's no way to say that 2 things that multiply to 75, either one of them is something or Or the other one is something like you couldn't say, some people would look at this and say, well, I can factor this into like 3a, and then, what's that, 2a minus 5 equals 75. So you could say, well, I've got this, but that doesn't tell us anything. There's no way to tell what a could be to give us 75. It only works when that's a 0. So do not try to go at it that way and skip some steps or things like that. Make sure you've got 0. And I say on the right-hand side, it could be on the left-hand side. It's all up to you and what you prefer. Okay, so let's look at this next one. Looking through it, the first thing I see is everything in here is a multiple of 3. So I can factor a common factor of 3 out, and I'll have x squared plus 10x, and that's going to be what? 16. So plus 16. And that equals 0. Again, there's no way for me to turn the 3 into 0, so I do have to factor this. And that 3 is just going to come along for the ride. I need two things that multiply to 16 and add up to 10. Well, 8 times 2 is 16, and 8 plus 2 is 10. So I'm going to have x plus 2 and x plus 8. Okay. My bottoms up method is technically done right now because I started with an x squared, not a number times x squared. So my bottoms up method is done. And now I can move on to the zero product property part that says either x plus 2 equals 0 or x plus 8 equals 0. That means that x is going to be equal to -2, or x is going to equal -8. And those are my two options, -2 and -8. On these next two, the first thing I want to do is get 0 on the right-hand side. That involves just taking everything from one side and adding or subtracting it to the other. So we get 5b squared plus 38b plus 21 equals 0. If I move everything on this one over, notice I'm always setting it up in this b squared, b, and no b kind of order. I'll do the same thing on this one. I'm going to put that 2, when I move it over, that 2r, in between these two. So I'm going to have 3r squared plus 2r minus 1 equals 0. Go ahead and pause the video right now and go ahead and just try to factor these. All right, so finishing these factoring steps, I am using bottoms up method, so I'm multiplying the 5 to the third term, and then I need two things that multiply to give me 105 and add up to 38. That was 3 and 35. It does take a little bit of practice to figure those ones out, and sometimes just some guess and check, which is totally fine. And by guess and check, I kind of mean what I do is I take 105 and start dividing it by different numbers, and I realize that 105, the digits add up to 6, which is multiple of 3, so I know I can divide it by 3. Sorry if that's a little bit, maybe not necessarily above, but if you didn't know that, that's a cool trick for knowing if something's a multiple of 3 is if its digits add up to a multiple of 3. So 1 plus 0 plus 5 is 6, and 6 is obviously easier to know that that's a multiple of 3. So yeah, it was 3 and 35 that ended up working out in my bottoms up step. The 35 over 5 reduced to 7, And the 3 over 5 didn't reduce, so I kicked that 5 in front of the b. That's the bottoms up part. And the one over here, I did the same thing. I multiplied that. I guess I didn't do that correctly, did I? Or didn't finish it, I should say. So you can see that bottoms up step here. I did multiply by 3 to, on the C. Okay, I took it off the A and put it on the C. So 3 times -1 is -3. Two things that multiply to give us -3 and add up to 2 is +3 and -1. This part will reduce to r plus 1. This part will not reduce. 1/3 does not reduce. So I kicked the 3 up in front of the r and leave it as a -1 right there. Okay? And then to use the zero product property again, that's kind of, I know that's the new thing, but realistically, that's the easiest part of this, because the factoring is still harder than solving a simple 1 or 2 step equation. I might have to do a little bit more writing, which again definitely takes me longer using a mouse than you using a pencil or a pen, but solving these equations shouldn't be the difficult part of these. I mean, except for the fact that you might get the occasional fraction. That's a 7 and I hate it. You might get the occasional fraction, but the zero product property tells us that this thing right here, these two things multiplying to give me 0, means one of them has to equal 0 or the other one does. So on this, I'm going to subtract 3 from both sides and then divide by 5. It's going to give me b equals -3 over 5. Again, I'm not writing those steps, but hopefully you can follow with me on those. And then b plus 7 equals 0 just means that if I subtract 7 from both sides, b is going to be -7. Okay? Another thing I've heard students tell me, well, don't you realize that it ends up just being the opposite of the second number divided by the first number every single time? I say, yeah, I get that, and I know why that is, but it's not a bad idea to think about, well, I'm going to subtract 3 from both sides, and then I'm going to divide by 5. Okay, that still works. But yes, it ends up being that it's the opposite of 3 divided by the number being multiplied by b, which is 5. Okay, sorry about that. On this one over here, r plus 1 equals 0 just means that r equals -1. Or if this part equals 0, I add 1 to both sides, then divide by 3. So r would be 1/3. And those are my two answers there. Okay, let's go ahead and turn the page. Look at a few more of these. Go ahead and pause the video again for me, and you can at least do the first 2. I want you to do the first 2 all the way through. Okay, hopefully those ones didn't take you too long. They were pretty much set up to just get you to use the zero product property, and that was about it for those ones. Okay. So all you had to tell me was solving each one of these equations in the parentheses for 0, and set those equal to 0 and solve. So on the first one, I get -2/3 or -1/5. On the second one, I get 2/3 or 3/2. Okay, again, some somewhat complicated answers, but they work out pretty. I mean, they're not terrible, right? And the work to get there wasn't the worst in the world, other than the fact that you didn't get nice, pretty whole number answers. Let's look at a couple of these. These ones are a little bit harder, and if you want to, you can pause the video and try them. I'm going to go ahead and talk through these ones just to help us out with our factoring skills just a little bit. So on the first one here, it's already set up with, it's already equal to 0, sorry. I do have to factor this side, but there's nothing in front of b, so there's nothing in front of b squared. So that makes it to where, I just kind of have to think about what two numbers multiply to give me +8 and add up to -9. That's actually a -1 and a negative 8, because negative 1 times negative 8 equals positive 8, but negative 1 plus negative 8 equals negative 9. Again, that takes some skill. I get it. If you're struggling with that, it's only going to take practice. Okay? Skills can be practiced and mastered. Okay? You just have to think that you can do it. Setting each one of these equal to 0. If b minus 1 equals 0, that means that b equals positive 1. Or if b minus 8 equals 0, that means that b equals positive 8. Okay? And again, these ones are a little bit easier because there's nothing in front of my b squared or my x squared, whatever variable is there. In this case, I have n squared. So I need two things that are going to multiply to give me 32 and add it to 12. Okay? Multiply the 32 and add to 12. That really sounds like an 8 and a 4, because 8 plus 4 is 12, and 8 times 4 is 32. So since I didn't say any negatives, they're both going to be positive. So we get n plus 4 and n plus 8. And again, if you didn't see that as quickly as I did, understand that, you know, I teach math for a living, so those numbers just kind of jump at me when I see problems like this. If they did, awesome. Maybe think about, you know, a future more heavily invested in math. Solving these two equations, if n plus 4 equals 0, that means that n equals negative 4. Or if n plus 8 is equal to 0, that means that n equals negative 8. So those are my two answers, and I'm not happy with that one. Kind of looks like an ugly 6, but it's a negative 8. Okay, moving on to the last two. These are the hardest, probably the hardest two problems on the page. So let's go ahead and work through them. Remember, I do want all these in my squared to the first power, you know, no variable. I want those in that order. So when I move these over, I am subtracting them over. So they're going to change signs. And when they change signs, I do want to put the 31 in first. And there's no, like, I mean, there's obviously a rhyme or reason because it helps me with my factoring. But there's no, like, secret, or nobody really ever said that you couldn't do that, I guess is what I'm getting at. So now I'm going to use my bottoms up method and multiply that 7 by that 20. So we get x squared minus 31x minus 140 equals 0. And now I just have to, you know, I'm kind of tasked with the difficult thought of what two things multiply to give me 140 and add up to 31. Well, this is where I kind of use my, okay, how about 140? And I'm just going to start dividing it by things. Again, there's no, you know, I'm not going to think too hard on this. I know I can divide it by 2, and then I get 2 and 70. That's not going to give me a negative 31. 140 is not a multiple of 3. See, we get that. What about 5? 5 and 28. I cannot combine those in any way to give me a 31, but I am closer. What about, that probably means I need to go a little bit smaller. Let's try 4. 4 and 35. So 140 divided by 4 is 35. And I like those numbers because I can find a way to combine them and give me 31. Okay. The key is that I was told that it is a negative 140. Obviously, using a calculator, it doesn't make a whole lot of sense to type in a negative every time. But I do know that one of these has to be negative. In order to get a negative 31, that means my negative 35 has to be, or sorry, my 35 has to be negative. So, what does that get us to? That gets us to our two factors. I'm going to say x plus 4 and x minus 35. So again, that part takes a little bit of effort, a little bit of work, but it is doable. I don't want anybody to think they can't do it, because you could literally take your calculator and, oh, that could have worked nicely. And you can literally take your calculator and go 140 divided by 1. I know what that's going to give me, but 140 divided by 2, go 140 divided by 3. I made the mistake of thinking, well, let's jump to 5. But if I hit 4, I see that I get 35, and I know that I can combine 35 and 4 in such a way to get a 31. Now I just have to make sure that my signs are good, okay, that my signs work out. And they do, so we're okay. Now, to finish my bottoms up method, I did have a 7 in the beginning, so I do need to divide both these by 7s. That is the crucial step to bottoms up factoring. If you don't do that, you're going to get answers of -4 and +35, but that's not going to work out if you try it in that equation. Okay, it's just not. There's no way. So I'm going to move that over. 4 over 7 does not reduce, so I'm going to go bottoms up on that 7. And kind of a crucial thing with bottoms up method, if we remember our foiling techniques, I'm going to just look at this problem. It's always first times first gives me that x squared, or whatever variable squared. It doesn't only give me that, but it also gives me the number in front of that x squared. In this case, it's a 1. In this case, it's a 7. Well, I already have my 7, so this one should cancel out. That's a little bit of the advanced thought behind that. So if that didn't totally make sense, just know that if one of yours doesn't reduce at all, then the other one's going to reduce entirely, and this one does. I get that -35 over 7 gives me -5. And again, that equals 0. So now we can use our zero product property to say, this one's kind of the hard one. I'd subtract 4, then divide by 7, but I would get subtract 4, or -4, divided by 7. This one's the easy one. X minus 5 equals 0. This means that x equals +5. Oh, not plus. It's not x plus 5. X equals +5. And there we go. On to the last one here. Again, it looks like a monster of a problem. That's because it is. We're going to get this 36x squared. I'm going to say minus 102x and minus 18. And that's going to equal 0. So now that first step's done. I have 0 on one side. I do need to factor it. But I'm going to go and see. I'm pretty sure everything in here is at least a multiple of 3. I know that. I think they're all also multiples of 6, which would make my life a lot easier. Because I know 36 is 6 times 6 and 18 is 3 times 6. I do need to check my 102. And it is a multiple of 6. It gives me 17. So I'm gonna factor 6 out first. And then I'm going to have inside 6x squared minus 17x, that's the one I just punched into the calculator, and then minus 3. Those numbers look a lot smaller and a lot easier to deal with. I would not want to come up with numbers that multiplied to 102, or added up to 102 and multiplied to 36 times 18. Wouldn't want to do that. That's a lot harder. Okay. I'm going to go and rewrite this now with my bottoms-up strategy, kind of moving that first number to the end, and that's going to be minus 18. See, this is a lot easier. Eventually, with enough practice at factoring, you're going to know that, well, maybe this isn't the one. No, not necessarily. Well, yeah, it is. Sorry. You're going to know when you get these two numbers, like one number off. Usually this number 18 is going to be in the mix. It's going to be one of the two things. Two things that multiply to give me -18 and add up to -17. That's going to be -18 and 1. So -18 and +1. Those add up to -17 and multiply to give me -18. So whether this number is one bigger or one smaller, that will tell you, at least just know that when it's one number away from your last number, typically, I'm not going to say it's always the case, but typically that last number is involved somewhere. So I get, we'll say x minus 18 and x plus 1. And remember, I'm not done. I am using bottoms up. So to complete that bottoms up idea, I do need to multiply both of these by 6. Sorry, divide both of these by 6. I just realized what I said. So dividing this by 6, 18 divided by 6 is 3. So we're going to get this still tagging on with this 6 on the outside, but we get x minus 3. And 1 over 6 does not reduce, so bottoms up that thing right in front of the x. Move that bottom up. And that's going to equal 0. And now we can use our zero product property. Okay, using our zero product property, either x minus 3 equals 0. That would mean that x equals positive 3. Or 6x plus 1 equals 0, so I'd subtract 1 and then divide by 6. So x equals negative 1 over 6. Now, maybe not the best time to do this, but I do feel like I've kind of breezed over this quite a bit. Sorry, let me, no, I don't want to do that. Don't do that. Don't do that. Sorry. Okay. Like I said, I do feel like I've breezed over this quite a bit. I do want to at least show, and maybe the end of the video isn't the best time to show it, but what I mean by when I'm doing this process of solving this equation, it is a two-step equation, but some people have a hard time tracking, like my voice, what am I saying versus what I'm writing. I'm not showing all these steps in any of these problems, but this is where it comes from. Okay, just solving a two-step equation to say that x equals negative 1/6. Again, maybe I should have done that earlier in the video, but just trying to save some time. We had a couple long videos last week. This one's getting there, but like I said, it is kind of a difficult topic. Okay, especially when I didn't get to help you as much through factoring as I wish I would have, and now we really need to use factoring, and not just to factor. Like, we got to use factoring to do something else. So this is where it all comes from. Again, this part was just kind of informative, a little bit, just trying to help you out a little bit on where that kind of last step is coming from. So hopefully that helps. Again, get started on the application problems. Next time in class, we are going to be taking our final exam. So review some stuff. Everything's kind of built on itself. There's a couple of sections that, like the graphing quadratic section, that's kind of a standalone. It doesn't really rely on anything else. But obviously, if you can solve an equation by factoring, you can probably factor just fine. There's probably no stress there. If you can solve a three-step equation, you probably don't need to really focus on how to solve a two-step equation, because you're probably doing that at some point through that process. So, there's only a finite things that you need to study, and I do want you to do better. So if you have any questions, make sure you ask me in class. If you don't get a chance, you can put any final exam questions in the comments of this video. I think that'll be will be helpful. But anyways, that being said, have a good day, and we will see you in class.